welcome back again. Start again by updating your table of contents. Today we are doing lesson 2.2, linear relations and functions. Make sure that you date it. And the essential question today is, what are two methods to make a graph of a linear function? So, a linear function is basically something that can be written as y equals mx plus b. So I'd like you to write down some examples of linear functions and nonlinear equations. Again, hit pause so that you can write down all these notes. And then these study tips, go back and just read through them and refresh your memory about those. Standard form, you need to know what that is. A key part of standard form is that a cannot be negative. Other than that, it just needs to be in the form of ax plus by equals c. Also, they cannot be, none of the numbers can be fractions, and the greatest common factor has to be 1. Again, hit pause. So, looking at some of the examples. Example 1a. Is this g of x a linear function? Well, we know it's a linear function if it can be written in the form of y equals mx plus b. And because it can be, it is a linear function. Because 2 is in the place of m, and negative 5 is in the place of b. Example 1b. We're looking at p of x. Is this a linear function? Well, this one is not a linear function because it cannot be written as y equals mx plus b because of that exponent. So this is a no. A linear function cannot have an exponent other than 1. And what about something like this? Now, if we were to rearrange this equation as t of x equals 7x plus 4, now it is in the form of y equals mx plus b, and 7 is our m, and 4 is our b, so therefore the answer is yes. It is a linear function. Go ahead and hit pause and read through this problem. So what we need to do is change 37 into Fahrenheit. So we're going to take this 37 degrees Celsius and replace it in for Celsius. So f of c is 1.8 times 37 plus 32. At this point, then you can just grab your calculator if you're not good at doing that computation. Then put it in your calculator. You get f of c equals 98.6. And that would be labeled degrees Fahrenheit. And we know that is the normal body temperature in Fahrenheit. Same type of problem. Read through the bottom section though. So this problem is actually a very simple problem to solve because of the form that our equation is given to us. Our equation is in slope-intercept form, and the important word there is slope. When we are trying to find how much things change as the x-axis goes up by 1, our Celsius is our x. So as that increases by 1, our slope is our rate of change on the y-axis. So this number tells us how much Fahrenheit changes for every 1 degree Celsius change, because that is the definition of what slope is. Okay, now a little practice of writing in standard form. Again, standard form is ax plus by equals c. And then there's a couple of qualifications that we need to do with that. So we need to rearrange our equation until it looks like that. So we'll write it out as y equals 3x minus 9. And now our 3x term is on the wrong side. It needs to be on the left-hand side. So I'll drop down my line and add 3x to both sides. And we'll write this as 3x plus y. In standard form, the x term has to go first and then the y term. And it equals negative 9. Okay, then we need to check, is our a term negative? So we look here, this is our a term. That is a positive number, so we're good there. We have no fractions. And then is there a common number that we could divide all three terms by? And that answer is no. So we are in standard form. Standard form is 3x plus, if you wanted to put a number there, it would be 1y equals negative 9. And the reason that we like to use standard form is because it makes it really easy to graph an equation. So let's start by putting this equation into standard form. So I would need to add 4 to both sides. And now this one is not in standard form because the a is negative. So to undo that, we could either multiply both sides by -1 or divide both sides by -1. Either way, the result is all of the signs become the opposite. So it would be positive 2x minus y equals -4. Okay, so now this part you don't need to write down. Just want you to follow along. If we think about a point on the x-axis, for example, that one right there, the coordinates of that point are 2, 0. Let's go over here and look at this point. The coordinates of that point are -3, 0. It doesn't matter where I go on the x-axis, the y will always be 0. If we think about the y-axis, that point would be 0, 4. A point down here would be 0, -1. It does not matter where we go on our y-axis, the x will always be 0. So to find a quick intercept, you need to put in 0 for y, and you'll find the x-intercept. You'll put 0 in for x, and you'll find your y-intercept. So this is what that would look like. 2 times 0 minus y equals -4. This is going to find your y-intercept. 2x minus 0 equals -4. That is going to find your x-intercept. So 2 times 0, that's really unnecessary. So -y equals -4 divided by -1. Our y-intercept is 4. Over on this side, the minusing 0 is really not necessary. So we're going to divide both sides by 2. And x is -2. Alright, go ahead and draw an x and y axis. And let's plot those points. So again, this is our intercepts here. 4 and -2. So on your y-axis, you need to make a point at 4. On your x-axis, you make a point at -2. And then you will connect those 2 points. And you can quickly draw a line using the x and y intercept. Another way you could have solved this problem, if it didn't say you had to use the intercepts, is you could have written it in y equals mx plus b form, started by graphing the y-intercept, and then have used the slope. Okay, make sure that you remember to do your summary and your questions down the left column of your page. And make sure if you have any questions to bring them to me in the next class period.